Chapter 22, Electrical Equipment Repairs. 235, Main Generator Repairs. The heavy repairs of the generator require the removal from the engine and is a complete dismantling. This heavy repair program includes the following: rebanding of the armature, if necessary, turning the communicator, inspecting the roller bearings, cleaning it and repacking, inspecting the bearing housing and the end of the frame, thoroughly cleaning both armatures, field weldings, and all traces of solvent infusion should be carefully removed with air compressed air. Insulation should be dipped and baked, and if necessary, may be needed only in a light spray coating of insulation varnishing. And in the case of the armature or rolling, and such varnishing needs the dipping and the baking, and adds a less useless material to the winding, and which decreases the heat in the transfer, reducing the air to the ventilation airing. To determine whether dipping or baking are needed, detailed inspection of the conjunction measure readings is also that required. Completing the rewinding of the generators, renewing the communicator, the absence of fires, manage insulation failures, and bed flushovers, mechanical damage, and highs is seldom necessary. High potential teating of insulation, diesel electrical strength of the grounding of essential is proper to the maintenance of the main generator on a diesel electrical locomotive under the effects of the high heat and dirt and moisture and combination of these insulation deterioration and service present twofold problem. One part of this problem is testing before the repairs are made, determining if any of the special work is necessary, if there are any weaknesses presenting in the other part of the testing after the repairs to make sure that the generator is suitable in condition for the normal period of service. 236. The auxiliary generator repairs. Generally auxiliary generator overstator overhaul consists of carefully inspection of the stator field assembly, armature assembly, the brush hole assembly, repairing assembly, especially with respect to VFX and necessary repairs. Also, application required testing, checks, cleaning, varnishing, treating, and auxiliary generator should be overhauled as follows: remove the armature, remove the discard or scrape ball bearings, clean, repaint field coils and leads, clean, dip, and bake armatures, turn undercut in the armature if necessary. Replace a string band if necessary. Assemble using the new double shielded bearings. Make certain that the bearing retainer nut is locked with the washer provided that is for its purpose. The following precautions should be observed to prevent bearing failure. When removing the coupling flange, blower, fan wheel assembly using a puller that does not apply to the load of the bearings, coupling the flange to the blower fan must be pressed on the shafts in such a way that the forces are not transmitted through the bearings. Care must be exercised in handling auxiliary generator to prevent pumping in the shaft. This can be damaging the bearings. Bearings which have been removed from the shaft at any time should not be used, and again, but this should be packaged, placed in the new factory packed bearings. 237. Traction motor repairs. It is necessary to recognize the distinction between the traction motor used in the switching locomotives that they use road locomotives. This tends to involve different periods of the time intervals rather than for the different maintenance procedure. For example, work done on a road locomotive or the given period of the greater than the work done on the motor of the switching locomotive. More frequently, active attention is required of the motors and road locomotives than other switching locomotives. The kind of repair attention, however, is generally similar. 3 important factors governing traction motor repairs and cleanliness: rolling bearings, communicators, and the maintenance program must be taken these account to prevent the trouble which might develop from any or all of them. 238. The growler test. The most common method of testing the short circuit in the field coils is growler test. The main repair should be equipped with a transforming or a growler for this purpose. The growler test is very simple. It is an effective method since no accurate electrical measures are required. Apply the pressure to the field coil when it is being tested in order to approximate the actual conditions when it is clapped in the frame. Pressure is not applied. The coil may not show defect on the test, but may be given the trouble the short-circuited turns when clapped between the pole tips and the inside of the surface of the frame, which the test operation after adjusting the knife switches to the desired number of the turns on the transformer. Place the removable portion on the curve or in place without a field coil. Note the deflection of the armature. When it indicates the value of the primary current, open the line of the switch and place the current in the position around the transformer core. Note the deflection of the ammeter. When it indicates the primary current, open the line, switch the place and the coil in the position around the transformer core. Close the switch to reapply the voltage to the transformer. If the ammeter shows the same defect as before, the coil is free. The short-circuited turns. Therefore, it is short-circuited. A much heavier current would flow in the primary coil of the transformer and would be indicated by a greater deflection of the ammeter. 239. Dipping and baking. Coils which have been in operation for 4 to 5 years should be dipped and baked in preventive maintenance measures. Some coils, such as field coils, are dipped before mounting on their core. In this case, the armature's entire assembly is suspended in the axial vertical position. The communicator on the upper end and the lower end of the compound up into but not including the communicator. The varnish impregnating compound is hot. The coils and armatures are cleaned and preheated in the oven before dipping. Dipping is 5 to 10 minutes, draining of the 5 minutes, then placing them in the oven for 6 hours at 300 degrees Fahrenheit, which armature is rebound and is baked for banding, and again for the banding. 240. Cables and wires. It is extremely important for the cables and wiring thoroughly inspected whenever the suitable opportunity presents itself. This includes insulted bus bars as well as wire supplies of cars only to exposed sections. In the later cases, resultant to a condition must be placed in result of the MEGR, or the high potential test. Cleaning should be done wiping the rags and using suitable solvent. If the solvent is used mentioned in connection with the repair of the main generators, the traction motors, all traces must be removed. When the cleaning is completed, it is good practice to paint accessible sections, particularly those exposed to dirt, which a good grading insulating paint with should be to the moisture resisting of the flame retarding properties of the insulation. If any of the section of the wiring is found to have deteriorated excessive because of heat, consider relocation of the wire to reduce such exposure. 241. The sequence testing. Generally, electrical testing instructions are issued in the manufacturer and each group of locomotives. These tests must be followed accurately. No attempt should be made to adapt approximate substitutions. The following discussion of the typical testing procedures merely tells a matter of general information. What is usually done, why it is done. Operating sequence and shutdown control switches tested as battery voltage, manually moving interlocks and controls after disconnecting generators so that it will not crank the engine as produced to the power of the voltage. The following is a partial listing of may be used in testing. Starting a circuit interlocks prevents the armature contactors from closing until the field contactors have closed. Fuel pump must operate the proper pump pressure show on the fuel gauge shutdown valve in the fuel line and must function with any of the safety devices such as a low oil pressure switch and high water temperature switch, according to the wiring in each individual case. Interlockings between throttle reversers as well as in directional auxiliary equipment such as sanders must ensure proper operation. Interlockers in the fan motor circuit shut other control circuits must function properly. 5. Traction motor field shunting and transition must occur at proper time sequence. Wheel slippage relays, ground relays, and must give proper protection in turning on the alarm and indicator lights. 7. Any replaced traction motor must be checked in proper direction of the rotation direction of the field of connection. B. Drying the internal heat. If the equipment has been flooded and the coils may be dried and by circulating current through windings to develop internal heat. The voltage is low, will not harm the insulation, but heat is not quickly dissipated, must be regulated. Experienced person seeing gas pressures within winding may also damage the insulation. The exact procedure depends on the type of the equipment to be dried and facilities available. 242. Insulation testing. General description. 1. Insulation should be tested periodically at voltage excess of normal operation voltage in order to detect any weaknesses which may cause a breakdown in service. Any defects must be remedied before failure occurs, and any route or 2 types of insulation testing are resistance tests, which indicate the pressure of the moisture, grease, carbon, and other dirts which cause grounding faults, indications, and miscellaneous failures which are not due to the breakdown of the insulation. Dielectrical testing, in which voltage above normal is applied to the circuit to determine whether it is withstand voltage stress which may occur during the abnormal operating conditions such as tests are confined to the main power of the circuits. The recommended test voltage is 1200 volts. An annual dielectrical test, 1 minute duration at a voltage at least 50% or 75% of the normal working voltage is set forth the Department Army Directive. The damage which may result in the installation failure during a properly applied dielectrical test is likely and smallly compared to the loss caused by breakdown while apparatus is carrying a heavy load. The reference should be made to the testing instruction for each individual locomotive for information on the terminal's connections and specification conditions for testing. B. Resistance tests. Resistance tests are adequate for the low voltage control circuits that are operating at 75 volts. Department of the Army directives do not require the dielectrical circuit test for circuits which operate below 150 volts. However, it is always desirable to keep the control circuit free from grounds. Although its high installation resistance does not necessarily indicate the high dielectrical strength of low insulation resistance does to indicate a low dielectrical strength. Control circuit of the new locomotive should have at least resistance of 1 mega ohm and should not fall into the less than one half of this value of the locomotive in service. An important feature of this testing is comparison of the reading of the under similar conditions at various times. As wide variation appears, excessive reading may be appropriate for the same conditions, temperatures, and dryness. The cause should be determined in the situation. Resistance rotating apparatus is useful indicating the condition of the installation, particularly before applying the high potential test. The recommended minimum merger reading of the power circuit other than main generator armature plus the communication field is a traction motor to remain in service on the locomotive for 1 mega ohm at 77 degrees Fahrenheit. If the if windings and parts of the winding or windings are oil or water soaked, the damaged parts should be removed, and regardless of the merged reading, insulation resistant windings varies greatly. Humidity, temperature as an approximation. Insulation resistance for DC motors halves for over 22 degrees Fahrenheit. Rise in temperature because winding temperature exempt. Those of known temperature cannot be measured accurately in shops. Recommended for the apparatus be permitted to level off the known room temperature before insulation resistance is measured. Dielectrical testing. Dielectrical test is not less than 1 minute duration. Should be made in the main power circuit annual whenever the insulation as apparatus has been repaired. It is important that the equipment is clean, dry, check for the merger of making tests. High voltage should be not applied unless the insulation resistance measures at least 1 mega ohm. When the motors are generated, radiators are clean and dry, about 7 degrees. It is considered good practice to insist on a 1 mega ohm above or before applying installation to any electrical machinery. In case the diesel electric locomotive, diesel electric equipment, the merger reading should be taken over 30 seconds prior to longer. If the reading is consistent, rises steadily in the continual application of the merger, it is considered that the installation is sound and can safely be tested. If the reading is unsafe, the safety and reading is unsteady. If the reading is unsteady and rises falls excessively with steady application of the merger volt, it's likely to be a leakage path may be present due to the presence of dirt and moisture. In later cases, it may not be put and safe in a high pot or the machine without further cleaning and drying. The testing leads to be securely connected to the circuit breaker. The test leads to be surely connected to the circuit before the power is applied to the text box to avoid the surges from the poor connections. 3. The voltage from the text box may be varied smoothly, but when decreasing the setting in order to avoid surges. D. The test box. Suddenly, application removal testing potential may result in surges as much as 100% over the intended test voltage. Excessively burned contacts and contact tips on the test box may result in undesirable fluctuations in test of the voltage. Text boxes have been fixed. Defiant secondary steps of voltage are certain of the producing surging if their primary voltage cannot be smoothly controlled by 0 to maximum. The most effective inexpensive modification for the text box is 1/2 or 5 kilovolts or A, not negative A. Capacity can be accomplished by adding a variac or primary winding. A variac has been ability to vary the voltage smoothly without steps, and as a result, practically no surging of the voltage. The V10 variac is used as 1 and 1/2 kilovolts test box. A V20 HM variac should be used as 2 or 3 kilovolts. A box with 2 V20 HM variacs is series at 4 or 5 kilovolts box. These variacs may be used in the 115 or the 230 volts as AC supplies. To use these variac connection, the test leads the machine circuit breaking tested before applying the power to the test box to raise the voltage test fall value within the variac holding the prescribed time, then lower the voltage to the zero as variac. Before removing and disconnecting the testing lead, maximum test voltage on the main power circuit should be 120 1200 volts to the ground. If the working voltage values at higher than 600 volts are established as a normal for any locomotive, corresponding high testing voltage should be applied. 243. The lining up of the generator with the engine. Generally, the operation of the generator sets requires for the armature shaft to frame to be in line with the engine crankshaft. The air gap equally spaced. The set eccentric with the coupling should be held, but the minimum is directable effects balancing the brush and the bearing aware. The air gap of the generator must be uniform within the plus of the or minus of 10% of the average under each main pole as well as under each of the communicating pole. Also, from the rear to the generator will have the proper electrical characteristics. Since the generator has only one bearing, the recommended method of aligning the air gap with the coupling is the engine of the generator. The aligning air gap. When the generator the installation permits, the air gap should be measured under each of the pole of at the coupling, and they should be done with the long feeler gap inserted through the communicator end. Since the generator has the non-uniform air gap under the main poles, the measurement must be made under the type of the pole pieces. As an alternative, radial clearance may be between the edge of the fan and generator frame may be used. If one point of the fan is used for reference, the fan is rotated so the measurement can be made between the point of the frame at the top of the bottom of each side. If the difference is measures in 880 degrees apart is less than 2/100 of an inch, the air gap must be may be considered satisfactory. Under no circumstances should be an attempt to use this end of the generator frame to sense an A frame to align an air gap. Lining coupling. The coupling is a line means of a dial type of the indicator fastened support extended out braided the armature flange with through a hole provided in one fan blade. The indicator is attached with the support that indicates the plunger rides against the face of the generator fan. The dial of the indicator shall be set at 0 top position. Readings taken 90% apart. The allowance of the plus or minus a hundredth of an inch, or bottom of the plus or 5/1000ths of an inch. Each side will result in satisfactory alignment with the coupling inside central crankshaft and armature shaft. Final operation. Since any of the movement of the generator frame affects from the coupling alignment of the air gap, reading must be repeated after both after settings. Experience will indicate the proper shim thickness to bring readiness readings from the limits specified only for the fuel length should be used, and each generator should be mounted pad. Not more than 3 shims should be used under each mounting pad for the one shim to exceed 6/100 of an inch in thickness. The thickness of the shim should be tapered, and necessarily the air gap coupling would conform to the specific limits. After a generator is coupled to the engine, the generator frame should be placed in a single bearing at the communicator end is located auxiliary to the void of thrust in either direction for the generator to have the float approximately 3/16 of an inch between the outer race of the bearing of the housing, the most coupled to the engine with no clearance between the bearing outer race and the engine side of the housing. When the crankshaft is forced toward the generator frame must be as far away from the engine as possible without putting at the end of the thrust on the coupling. This arrangement provides the maximum amount of clearance required. By expansion of the generator shaft and crankshaft as they heat up, the armature shaft should be forced toward the coupling, the end of the generator before coupling to the end of the engine. 244. The bearings. The term anti-friction bearing is applied to all ball or roller bearings. To distinguish a roller type of the bearing, the common sleeve, the type they are mostly styled, the type of the roller bearings in single roll ball, all double roll ball or self-aligning balls, single roll ball or double roller, self-aligning roller, tapered roller, further modifications inner outer space of each. The The types of suitable diesel-electric apparatuses are limited. If you design them properly applied with the lubricated ball or roller bearings needed much less attention than the sleeve bearings. They are generally used in the main generators and armature bearings and traction motors, belt-driven auxiliary generators, exciter bowler motors, nearly all electrical rotating apparatuses of a diesel-electric locomotive. Each time a motor is overhauled or cleaned or inspected, repack the roller bearings. Clean the bearing parts with kerosene or other petroleum cleaner. Do not allow them to lie around old grease in them. Do not use compressed air on a bearing. It may contain moisture which would cause the corrosion of races of a roller. Do not take cages apart. Inspect bearings for parts of the defects. Examine the inner race under the good light. Look at the roller path. Examine it for the flacking or cracks. Examine for the pitting and the signs of excessive wear. Any excessive amounts of dirt. Examine the side surfaces. Bore inner race of the evidence. Rubbing, turning on the shaft on the communicator end of the bearing traction motor. Look for smearing on the flange or thrust collar. Examples. Examine the outer race of the roller or balls. Examine the cage for wear. To prevent corrosion immediately after cleaning the inspection, dip the bearing in a light mineral oil SAE10 heated at 203 degrees Fahrenheit. Drain the bearing and wrap it in wax paper and keep it clean. Clean the bearing housing fingers adjacent parts with kerosene. Safety solvent or other petroleum cleaner. After cleaning and wiping the housing dry, dip the fingers adjacent in the parts of the SAE10 mineral oil heated at 203 degrees Fahrenheit. Drain the stored parts of the dry and clean place. Only in a shaft having two bearings, one is suitable for the taking end of the thrust. Normally it is clamped rigidly to take the thrust, and the other bearing must be free to allow the movement of which results from the expansion and the contraction of the shaft when the temperature change. For ball bearings in which balls normally are given the grooves in the inner or outer race, is necessary to allow for the free fit between outer races and the bearing supporting housing. The fit should be loose enough to allow the outer race to move the horizontal within the shaft. Sufficient clearance should be provided within the housing to permit the longitude movements. For the roller bearings, it is frequently to practice to provide one to the racers. One of the races with the groove path of the rollers, while the other races is cylindrical, thus allowing the longitude movement of one race with respect to the other. Single. C. Since one end of the armature shaft of the single bearing generator is supported prior to the application, the armature usually rests on the pole pieces, in which result in the armature shaft is now perfectly aligned with the bearing housing. For a reason for the sufficient clearance of most of the allowed pill between the balls and rollers of these races to permit the slight angular and of the shaft and L self-aligning type of the bearing must be used. D. Since the locomotives are subject to wide range of operation conditions such as generator parts of the shafts, bearings, and balls, rollers may be subjected to the high temperature which causes an expansion of the metal. For this reason, the clearance normally allowed for the industrial anti-friction bearing are not sufficient for the diesel-electric generators. The traction motors and special free-fit bearings should always be used. These clearances are measured under the roller balls and after the bearings are assembled with the shaft and the housing at the normal room temperature. It is customary to ensure the tight fitting of the inner race in the ball or roller bearings at the time of the shaft, and on the shaft, heating the race of the oil temperature to 212 to 257 degrees Fahrenheit, allowing the bearing to remain in the hot oil for about 1 hour before applying it to the shaft. The fit of the other outer race of the infit housing, however, differs for the different type of the bearings. For ball bearings where longitude movement is on the shaft means the outer race must also move, the outer race should be such a fit that it can be pushed into the housing by hand. This also prepares cylindrical self-aligning roller bearings. For large bearings, it is customary to limit the housing bore to 0.002 of an inch greater than the outside diameter of the outer race. For the smaller the bearing, the adherence of the talons may be less rigid. For the roller bearing, which have one cylindrical race, the outer race is usually large than the housing bore of 1/1000th of an inch. To give the tight fitting, the replacing bearings after the equipment has been serviced. However, it is also well as check both the bearing and the housing to ensure good fit. 25 communicators. The 25 communicators regular maintenance. The proper maintenance care of the communicators eliminates excessive stone. Each time a road locomotive causes this maintenance point comes to the maintenance point. When the diesel electric locomotive is maintained, the communicator should be touched up with a canvas covered block to prevent the excessive formation of oil scum developing, a condition requiring heavy stoning. On switching locomotives, this work should be done at the time of the monthly inspection. If excessive formations of scum cannot be removed from the canvas, the use of the fine finishing stone lightly applied may be required. This will permit the operator to touch up the communicator lightly and maintains the true surface on the communicator. Stoning. A communicator may have a smooth glaze of chestnut color in a satisfactory condition. Slight burning often occurs at the edges of every few bars due to the method of winding to getting high electrical efficiency. No maintenance retention is required for this type of defect. However, such spots are deep enough to cause a brush to leave the communicator, or the communicator is deep, dirty, or smudgy. It may be necessary to smooth surfaces and bring the communicator back to the concentric of means of grinding stone. Eccentrically may be centered by clamping a dial gauge on the frame of the generator of the motor, retaining the armature by hand. One communicator bar distance at a time. The dial gauge measures the thousandths of an inch variation of the communicator radius. Any eccentric of 1/1000th of an inch within a distance less than the brush's space around the communicator may indicate the necessity of stoning. For bad burns, extremely eccentricity, it may be necessary to turn the communicator on a lathe. For the motors on the generator having a roller or ball bearings, the satisfactory stoning job is done as follows. Using a grounding rig with being clamped firmly to the floor of the machine with two directions of the feed for the stone. Operating the motor, the generator is slow idling speeds. Operating the traction motor, jacking the wheels off the rails, connecting the motor to the welding generator as a source of power, as removing all pulsating torques, such as compressor drives, which when they turn a generator communicator. Take extreme light cuts at the first unit until the communicator approaches the true condition. Avoid heavy cuts as the cause of some deflection of the rig that may not produce consistency. Take a final cut stone with a fine grade of stone. Check the true communicator with the dial connector. Clean out the undercut slots between the bars in the minimum of 3/64 of an inch. Leave no mica on the sides. Using rotating saw, clean and bolt by hand with a piece of hacksaw blade. Chamfer the edges of the bar slightly at the slots with the fine sandpaper with non-emery cloth. Use a sandpaper laid on the communicator under each of the brush to sand off the face of each of the brushes to the communicator contour. See brush pressure. If the operation of the communicator of the brush grade and the pressure could be recommended by the manufacturer to measure a brush of the strip up that attached to the spring of the balance should be slipped under the brush hammer. The middle of the brush pressure is determined by the pulling of the hammer away from the brush in the direction of the hammer movement. This pressure should be determined on the base of the half-worn brush, or not a new one. Turning. If the communicator is badly worn or burned, remove the armature for the machine to turn the communicator in the lathe. Remove only enough copper to give the uniform surface, after which the side of the mica becomes segment should be recut. The communicator surface polished and cleaned whenever possible. Turn the communicator support in the armature in its own bearings. If the armature is held on the last center, make sure that these centers are true with respect to the bearing seats. Before turning in the communicator, make a suitable covering to keep the chips and dust from working into the armature. Make sure that the turning post is set, that the ways are always absolute parallel to the communicator, that they are fastened and braced and securely. Use the side cutting tool while pointed and grounded about 1/16 of an inch. The cutting side of the point shall be given more rake as customary for working iron and steel. The tool should be sharp enough to make clean cuts, smooth cuts, without dragging copper over the mica. While turning the communicator, it should be run at a peripheral speed of approximately 300 feet per minute, which is about as fast as the tool will cut without burning. With a file round off the ends of the communicator, the bars at least 1/16 of an inch radius, while the communicator is still in the lathe. After the communicator has been turned under the mica, the same manner was the stoning. 246 traction motor pinion gears. Generally, the rules carried must be taken avoided bumping pinion gears and pinion ending the armature shaft and shipping the handle in the prior application, applying the removal of the traction motor from the tracks. The pinion gear of the end of the armature is bumped against the heavy object. The communicator of the end of the bearing shall be examined. The damage of the thrust portion end of the bearing race. Extreme care should be used in handling traction motors to avoid damage which will result in the failure of the motor due to the armature shaft locking. Pinions on traction motors as road surface should be pulled at intervals about 250,000 miles, and an armature shall be manual flux for defects. Whenever pinions are pulled for any reason, the armature should be magniflux and placed in perfect condition before pinions are again applied. Removal procedure. In removing a traction motor pinion gears, use a suitable gear puller. Never heat a gear before pulling. Never use a wedge between gear bearing cap. To prevent damage for the anti-friction bearing, remove the armature from the motor from the frame with a suitable V-shaped supports. Then pull off the pinion gear. Never strike the pinion gear with a gear puller or the sledge or a heavy object with an armature that is placed in the motor frame. See mounting procedure. In replacing the traction motor pinion of the gears, clean the armature shaft of the bore pinion gear. Thoroughly remove any of either the surface or spot cold pinion gear on the shaft by hand until at least 85% is obtained. After checking the fit between the armature shaft and pinion gear, mount the pinion cold in the shaft by hand. Record the piston of the gear on the shaft with respect to the end of the shaft. Makes the measurements using preferable micro depth gauge and set suitable frame figure 104. Make the points measure at the end of the points so that the pinion can be mounted exactly the same manner after the heating the pinion in any of the oven or oil until it has reached a uniform temperature is required. The number of the degrees about the shaft temperature. To check the pinion gear for the temperature for the hand pyrometer. Never permit the temperature of the pinion gear to exceed 375 degrees Fahrenheit. Be sure the maximum advance is obtained by using a dummy pinion nut which has loose thin threads to permit the quick and tightness. Use a suitable spanner wrench at the proper tightening of the nut before the pinion gears cool. After pinion gear has been cooled, remove the dummy pinion nut and check the pinion gear carefully for the measurement of the proper device. If the mounting of the satisfactory, applies the tightening and regular lock washer and nuts. 247. Traction motor axle bearings. Tolerance of the traction motor axle bearings vary slightly depending on the manufacturer of the locomotive and, if necessary, used in road switcher service. The appropriate manufacturer bulletins and appropriate technical manuals should be followed when bearings are to be repaired and renewed. Whenever the traction motor is removed from the locomotive, the bearings alignment should be checked before the motor is reinstalled in the locomotive. If the bearing should be showing the sign of the cutting, scraping down, or to the new surface too badly worn, replace a new one. Before the installation bearing, examine the journal examine the journal for roughness or cutting. Hot bearings will occur occasionally and are usually a result of one of the following: insufficient amount of oil, dirt working in the bearing, improper package, waste, excessive end play in the track axle, new bearings in which insufficient clearance, traction motor noise clamped, and truck frame. See if the bearings are hot and use the following checklist. First, check oil level in the oil cavity. Examine the waste packing and to make sure it has not fallen away from the journal. If the bearing has been recently installed, check the clearances that might have been set up too tightly. 248. Traction motor axle pinion bearings. Serviceable life of railway gearing depends very largely upon the type of the service in which they are used, quality, maintenance, the lubrication in which they receive the gears. A high-speed road service should be maintained with the more rigid standards that are necessary for the gears to switch it. It's your duty. Gears must become unsuitable for further service. Gears may becoming unsuitable for further service for a variety of reasons. The most common one is which wear. When a wheel is removed from the truck of any reason, the gears should be thoroughly inspected, condemning the limits of the axle pinion area gears and given the inspection procedures as follows. Visual inspection manual flux midship and spalled and pitted teeth pinion axle gears should be condemned within more than 20% of the total working surface of the teeth are spalled and pitted, or axle gears should be scraped. This shows you the gears of the pinion gears for the axle thing with the armature shaft gauge. When either one working with method of using a pinion gear, advancing the gauge. When either one of the working surfaces is worn to the point whether it's 1/32 of an inch deep exists in the root of the gear of the tooth, whether the content contact of the pinion ends. Check the weir limits determined on the dimension across the tip of the tooth. The most minimum allowable dimension is at this point 3/32 of an inch for an axle gear and 1/32 of an inch for a pinion. Like scuffing, the characterized vertical rock tick lines is indicated, but the faulty lubrication is not correct. Many results ultimate destruction of the teeth as heat generated as a result for the condition that may cause damage to the armature bearings. When the gear is humped at the pitch of the line and step of the roof of the top of the tooth, it disturbs the appliance of the new axle linings or pinion armature shaft. When the gears in the hump at the pitch of the lining step at the roof of the tooth is distributed by the application of the new axle linings limited outer gear that will operate interference stress of the torsional vibration until battered new mating fitting operation under the abnormal conditions may lead to the fatigue failure of gear teeth and shorten the life of the armature windings. Chapter 23, Demolition of Locomotives to Prevent Any Enemy Use.